find the derivative for this inverse trig function. We will start by letting y equals secant inverse of x. And then we're going to rewrite it using the definition. Then we have x equals secant of y. And in the same time, we also want to indicate the restricted domain for further uses, which is y as in 0 to pi over 2, union from pi over 2 to pi. Also, the range of the inverse function. Okay, then what do we do? Then we will take the derivative with respect to x on both sides of this equation, which is also called the implicit differentiation. And that is going to take us to d over dx for this x, and then d over dx for this sine of y, like this. So this will require some chain rule and also the formula for the derivative for this thing. So I'm going to write it here to avoid some confusion. D over dy for this secant of y is going to be secant of y multiplied with tangent of y. If you are unfamiliar with this formula, you can just check the textbook that is from the calculus 1 formula provided. Okay, so we will use this together with the chain rule. That's going to take us to this secant of y multiplied with tangent y, and then dy dx, and then this side is going to be 1. Okay, and then we can solve for dy over dx by dividing both sides like this. So dy over dx is obviously 1 over secant y times tangent y. So this derivative is almost done, except that it's still expressed in terms of y instead of in terms of x. So the rest of the work is for us to replace this expression into something purely in terms of x. We see secant of y can be replaced with x. Okay, so let's maybe try to express this tangent also in terms of x. You may want to think of the formula, the trig identity, which is 1 plus tangent squared equals secant squared. And then you can solve for tangent by moving this to the right side and then take a square root. The tangent of y can be expressed as this secant squared minus 1. Of course, you will need a plus or minus sign. And then we might be able to eliminate the sign by considering the range. But after we check, we see when y falls in this, tangent will take positive value, and on this, tangent will take negative value, which does not really help us to remove the sign. So instead of using this method, having to discuss in 2 separate cases, I'm going to take an alternative approach. The alternative approach is that we will express this a little bit differently. We know secant is just 1 over cos. So I'm going to flip this to the top. Cos of y divided by, this is going to be sine of y divided by cos of y, which can be written as cos square of y divided by sine of y. Just a little trick here. And the reason why I do so is because we can see directly from this expression that cos squared is greater than 0, and also sine of y is also greater than 0, provided that we know y is in this range. So we can deal with this very easily without having to discuss in two separate cases with those annoying signs. Okay, so let's now try to express this, and then we replace them with x. We will have cos square of y equals just 1 over secant squared by definition, which is 1 over x squared. And then we will express the sine of y is going to be the square root of 1 minus cos. But in this time, we don't need a plus or minus sign because we have already known that in this range, sine is going to be positive. Okay. Sine of y is positive because of this. Positive. And then, okay, so that's going to take us to 1 divided by, it's not 1 divided by, square root of 1 minus 1 divided by this, by replacing this with that. Okay, so, and at last, we're gonna do the substitution. That's gonna take us to this divided by that. So 1 divided by x squared, 1 minus 1 divided by x squared, which could be called the final answer. But if you don't prefer this expression, you can turn it into this by multiplying one of this absolute value into this this square root, which I actually less prefer. Like this. So we can figure out the final answer without needing to deal with those annoying signs.